Good evening. I'm Susan James. I'm a library manager here at Bayliss Library as well as assistant director of the Superior District Library. I'd like to thank David Lawrence and Michael Boguth for speaking tonight. I'd like to thank the Superior District Library Director, Ken Miller, for allowing us to use the library after hours, and for help with the refreshments, Mary and Carolyn. Let's see, other events are in our newsletter in the back of the room. You're welcome to take one. And Mary spoke about many of them. As far as the library, the Friends of the Library's silent auction is out in the lobby. And so I brought the box in. If you see something you're interested in, you're welcome to fill out a form and drop it in the box. Bayliss Library regularly hosts winter and spring weather spotter programs. Next week on Thursday, October 30th at 6 p.m., the library will host a winter weather spotter program that you're all invited to attend. It was at one of such programs that I spoke to meteorologist Jim Kaiser, who strongly supported the idea of providing a historical weather program for the Chippewa County Historical Society. Tonight, David Lawrence and Michael Boguth will present just such a program. David has been a National Weather Service forecaster since 2002 and has worked at the Gaylord office. He's on the right. Gaylord office since 2007. He holds a meteorology degree from Penn State University and is a huge fan of Northern Michigan's winter weather. Michael has worked for the National Weather Service since 2004 and has been a National Weather Service forecaster in Gaylord since 2006. He holds a meteorology degree from the University of Michigan. Their program is titled Historic Weather Events of Michigan's Upper Peninsula. Please welcome David Lawrence and Michael Boguth.
All right, well, we'd like to say thank you all for coming tonight, and I'd love to give a second round of applause to whoever brought the food, if we could do that. For sure. Man, we just stuffed ourselves, and we're going to eat more. So if you see us munching,
I will be over here guarding.
yeah, you just keep an eye on that.
Just keep an eye on.
We are here to talk, obviously, about some very interesting weather. It's no surprise and no shock to any of you that the UP is known for some quirky weather, some very changeable weather. Here, anyone agree with that? And just some very fascinating things that have happened over history, whether it be big storm systems, different types of weather, all sorts of, basically everything that you can imagine can happen up here. So we thought we'd be interested to sort of compile a list of some of the ones that at least stick out in our minds from a historical perspective of things that have happened up here that are definitely not what you would call normal. So very fun. We're going to have a lot of fun with this, very informal. If you have any questions or we confuse you or anything like, just throw a hand up and we'll be glad to chat. At the end too, if you want to ask us any weather questions, we'd love to chat with you about that. So you guys ready? Yeah. Let's do it. All right. And this is really not a top 10 list or anything like that in any specific order. These are just very interesting programs.
Lights off?
Very interesting stories.
That helps. So.
Okay.
Yeah.
Perfect. So let's start with the Great Storm of November 7th through 10th, 1913. Does this ring a bell in anyone's mind? Off the top of your head, this is obviously famous enough to warrant its own recognition plaque along the shore of Lake Superior for some truly horrendous weather conditions that were experienced. Let me just plug this thing in right here. It always helps to plug in the USB connector before you start to talk. But this was known as the White Hurricane, and this was, and remains to this day, one of the deadliest and one of the most destructive storm systems to impact the Great Lakes of the last 100 years or so. In fact, last year was obviously the 100-year anniversary of this event. Here's a summary of that. Again, one of the most infamous storms in recorded history of the Great Lakes. At least, by all accounts, 258 lives were lost on the Great Lakes from this event. 12 ships were sank during this storm, 30 other vessels were crippled, and I'll tell you why that was here in just a minute. It's kind of an interesting look back at the early days of meteorology before it became what we know today. So 8 out of those 18 ships that were battling the storm on Lake Huron sank. There's a list of them. Those alone accounted for 187 lives lost, and I'll show you again why Lake Huron was such a tricky place during this event. A couple of interesting excerpts from the local weather bureau reports that we continue to put these out today, but these are ones that people would take sort of notice of. Duluth, by far, very impressive. During this storm, the magnitude of velocity ranged anywhere from 34 to 62 miles per hour between 1 p.m. and 7 p.m. Sault Ste. Marie, while the wind reached a maximum velocity of only 37 miles an hour, here you can see vessel masters reported that on the open lake it was anywhere between 60 and 80 miles an hour, and it is well known that Sault Ste. Marie in certain wind directions tends to have a little bit more cover as they compare to areas just offshore as we get out into Whitefish Bay. So it's not really shocking that they didn't necessarily record the highest winds during the storm from right here in the Soo. Now here's a look at the different ships that were either that sank during this event for the most part or were severely damaged, and you can see them, they sort of dot the shore. But look at this one area down at the Lake Huron here. Very, very large amount of ships that were damaged or sank during this event. And the reason for this is actually quite simple. Meteorology has undergone extreme changes here in the last 100 years. Things that we thought we knew about weather back in the day, some of them still apply to this day. Some of them are sort of hard, fast scientific rules. Others have been learned the hard way, quite simply, unfortunately, over the years. This was one such event. Now, it was well known that as we were approaching this event, before everything kind of went crazy, that we had a low pressure area, and as you can see this low pressure system right here, essentially tracking up across Michigan, and then expected to head off into Ontario and eventually Quebec. Okay, this was the expected storm system that would impact the Great Lakes. This storm was fairly strong, as a lot of them are during the month of November. It's obviously, there's a reason we call it the gales of November. But this was the only expected storm. So essentially, as this storm would have passed, winds always flow in this direction around it. So we're talking essentially counterclockwise flow. Out ahead of it, we would have expected southwest winds or southerly winds up the lake. And as this storm departed, we would have expected sort of a westerly component on the backside of this, okay? That was the official forecast. So these ships that were tracking up Lake Huron decided, great, we expect westerly winds gusting to maybe 25 knots. Certainly not unheard of on the Great Lakes, right? This is November after all. How can we best avoid or protect ourselves in that? So what they decided to do was hug the Lake Huron shoreline on the western side of the lake. Does that make sense? So they would have basically all of this wind would be coming off of land out into the water, and they would not have as strong of conditions because winds are going to slow down as they go over land. Does that make sense to everyone? It's a great strategy. They still use that to this day based on what the forecast was. What they did not realize is that something very interesting was happening down here in Florida. There was a second area of low pressure along this cold front that was getting ready to develop. And what I want you to notice, see these lines here? These are temperature lines. This is 30 degrees, 40 degrees, 50 degrees. And what happened is these lines got closer and closer and closer together, and what that is indicative of is the potential in the atmosphere for goofy weather to happen, right? Weather doesn't typically happen if it's sunny and 80 degrees for 6 days in a row, right? Or in the case of this week, sunny and hopefully 50, right? If we're lucky, maybe 50, but still, not a whole lot of weather's going on. When you think about changeable weather, what do you think of this time of the year? 70 degrees one day and it's perhaps snowing the next, right? Everybody, understand where that's coming from. You can get changeable weather along these very tight temperature gradients. This was occurring across the southeast states very rapidly, allowing the second area of low pressure to develop and essentially ride up and along this front and develop very, very quickly as it did so. That was completely unforecasted from this event. And that is where things went crazy. Essentially, that low pressure system developed right here over Florida, tracked into up the coast of Virginia here, and then became so strong that it actually took a westward track and bent back into the Great Lakes, essentially ending up over eastern Lake Huron by the time we got to, I think this was the morning of the 10th or something like that. What that did, and remember our flow around this low pressure system is like this. Instead of west or a northwest wind, it was a very strong north or even northeast wind. The tighter, these are different lines of equal pressure. The tighter these are packed together, the stronger the wind speed is. And I don't know if you can see this, but this is a tremendous gradient from the center of this low pressure system outward. In fact, to give you that follow weather, the lowest central pressure of this storm was 969 millibars, which is very, very significant. Most of the storm systems that impact the Great Lakes, even the strongest ones in November, are somewhere on the order of 990, 995 millibars, something like that. So this is a very deep, very intense area of low pressure, completely unforecasted, which resulted in winds coming out of the north. Instead of being out of the west at 15 to 25 knots, they were out of the north anywhere between 40 to 60 knots. Slight difference if you're a captain, correct? Just small. And unfortunately, what that did was that allowed all those ships that decided to hug the shore of Lake Huron here, it forced them right onto shore and sank them almost immediately. They had no chance to escape this wind because they were fighting wind to try to get back out to the other side of the lake if they could, but there was no way they could. This wind was essentially penning them down exactly where they were. And so, unfortunately, all of these ships that were in this general vicinity basically stood no chance. And that's why we saw such a large number of ships that were taken down during this event. And this still, I think, remains one of the deadliest recorded storm systems to impact the Great Lakes even to this day. So just a truly remarkable storm that impacted a large portion of the area. And of course, as you would expect with such storms, during this event, it was snowing out here in the western UP, and it was in the 60s and 70s over here into the eastern Great Lakes. So again, a huge gradient in temperature between these two areas, and that's of course where we got our very strong storm system. So any questions about the 1913 White Hurricane? Yes, ma'am.
I was wondering where the marker is.
You know, I'm not sure off the top of my head.
The what?
This marker right here.
Oh, yeah.
I want to say that it's on the Lake Huron coast.
Is it Lake Huron? Yeah, I think you're right. I think it is over toward.
I've seen it. Harrisville, somewhere.
It's not Rogers City, is it?
Maybe Rogers City. It's somewhere along that northeast lower coastline.
Okay.
Yeah.
Yeah. It is what happens when you do a Google search for the Great Storm of 1913. I was actually shocked to find that. That's pretty neat to actually be able to see that. So I'll turn the next one over to Mike, and he'll talk about one that's a little bit fresher in a lot of people's memory. That'd be the 1975 storm.
Thank you, Dave. No, I need the Gordon Lightfoot theme song for this one. Sticking with that Gales of November theme, as Dave was talking about, November is the season for significant Great Lakes storms, simply because the temperature gradient across the nation is increasing. You got the cold air from Canada intensifying, but yet you have some lingering summer warmth off to our south, and it sets up the classic conversion of air masses, the clash of air masses we all hear about on our daily news. And when things are just right, you get these phenomenal storms, and they tend to occur in November. Another reason November is so famous for the Great Lakes weather is there's still ships on the water. Ships are trying to get their last voyages in before the season closes, before ice cover. And this kind of happened in November 1975. Things came together, unfortunately, for this horrific incident with the Edmund Fitzgerald, which, as we all know, occurred, about how many miles out of Whitefish Bay or Whitefish Point? What's the song say?
12.
Yeah, 15 miles, I think. Yep. And you'll see why they were in probably the most vulnerable position to be on Lake Superior at that time. Dave showed a map pretty similar to this. This is your classic. Dave was talking about the storm that developed in the southeast states. This is your more typical November storm track. Still early in the fall season. The low pressure likes to form down here in the south central states. We're a lot of times the eastern seaboard still well into the warm sector that time of year, and that storm likes to ride right up the gradient. And that gradient, like I said, that temperature gradient can be extreme. And those extreme temperature gradients spawn deep low pressure. This was a classic case of one. We call this we call it a panhandle hook kind of system from the Texas Panhandle, Oklahoma Panhandle that comes right up through the western Great Lakes. This time of year, the Great Lakes, of course, are by no means warm, but they're a lot warmer than the environment around them, the air around them. So storms actually like to intensify when they get to the warm Great Lakes waters. This one did that and reached its peak intensities across Lake Superior. Here's some computer simulations of that event. Low pressure, like I said, a very typical track right through the western UP. But we see many Novembers, but this one reached rather extraordinary depth for the season. 982 as it came off of Marquette, and eventually up into the 970s as it strengthened over Lake Superior's warm water. The Edmund Fitzgerald was making its run from, I believe, Duluth and taking the northern route because of the northeast winds. The storm was well forecast. This was not a surprise event. So they were hugging the north coast of Lake Superior because of the northeast winds on the backside of the slough to get protection from the Ontario coastline. But eventually they had to turn south towards Whitefish Bay and make that run. Unfortunately, they made that run as the low was passing off to their north, and they got into the backside and the strong south or the strong northwest winds that cut across the whole complete length of Lake Superior. The longer the winds blow over open water, the greater the chance for great waves. And you'll see some of the wave heights that were at least recorded during this event. Some of the winds, like I said, here's the Edmund Fitzgerald where it sank. Look at these winds along the whole length of Lake Superior. You know, this is what, almost 200 miles of open water. They're right here in the worst possible position. Winds of 45 to 50 knots, and these were sustained. Look at some of these gusts reported by the Anderson that was just following the Emmett Fitzgerald by several miles. Gusts of 75 knots, 86 miles per hour. So you're talking tremendous fetch, tremendous open water length, tremendous wind. You combine that, you get tremendous waves. Look at these waves here. 24 to 26 feet in the southeast basin of Lake Superior. Once again, simply because of the strength of the wind and there is no ice on the water this time of year yet. So that's all open water that wind gets to traverse. And you're at this end of the lake, you got all that open water and those waves 24 to 26 feet at the time of the Emmett Fitzgerald sinking. Oh. It's a famous shipwreck, probably the most famous in Great Lakes history. The storm Dave talked about was by far more of a damaging event. A lot of ships, what were the total in that year storm? Like 13 or whatever sinkings? This was the only one, but probably the most famous Great Lakes, probably because of the time it occurred. You know, getting late 1975, people are thinking ships on the Great Lakes sinking, and that was from way back when. But it just goes to show you how rough the waters can get in the Great Lakes in November. Anyone recall this event at all?
Yeah.
Any interesting stories to tell?
Yeah, I got a small one. We lived on the St. Mary's at the time on the west shore, and while this was going on, it was the day with the highest winds, and I think at one point the Sioux recorded more than 90 miles an hour.
It wouldn't surprise me.
And we had two big trees come down, and then we had our own little incident where our canoe, and I saw this, which was down near the river, got picked up, and I think it was 15 feet in the air, just sailed once it was in the air, the wind was under it, and I don't think it came down until it was a good 100 feet out into the St. Mary's, and off it went across the river.
It just shows how strong that wind was. Like I said, you know, this kind of event, believe it or not, the strength of this flow is nothing extreme. We see this on probably once on the order of every 5 years, but just everything came unfortunately perfect together for this to occur. Now we're going to go to an event that's near and dear to my heart. I'm a snow lover. That's why I live where I do in Gaylord, Michigan. But believe it or not, I actually lived in Sault Ste. Marie for 2 years. The best 2 years of my life, 1995. Moved up in August of 1995. And like I said, I'm a snow fan, so we all know what I'm getting at. There was an event shortly after I moved here that tops the charts for me. And then I moved back downstate to eventually go to college in 1997. And that, of course, is the Sault Ste. Marie blizzard of December 8th and 11th, 1995. Now, you have to remember this one if you lived here. Okay, this thing was phenomenal. At the time, I was actually working, I was fortunate enough to get a job at the casino. And I was working the midnight shift, and I went in on the, I guess it would be the 8th or 9th, with the forecast of about 5 to 7 inches of snow. There was I think a snow advisory in effect at the time. While I'm at work, unloading a truck that was in there, that had been sitting all day, and I'm looking out the window, it's like 2 in the morning, and it's literally snowing like 3 to 4 inches an hour. And we got off work, and when I got off work, the snow stopped, but we couldn't get to our cars. My car was completely buried up to about the middle of the door. Well, they were kind enough to give us rooms at the casino that day, because we couldn't get home. We hung around the rooms. They eventually dug us out. But we'll hear about this event. Shortly after they dug us out, I got home. We got hit by another 30 inches. There was a brief break that a lot of people don't remember. There was a good 10-hour break, and I'll show you why that break occurred. But to this day, this is one of the greatest single winter storm events to ever impact the state of Michigan. So December 8th through the 11th, 1995, 61.3 inches of snow. To put that in perspective, the Detroit average for the whole winter is about 35 inches, okay? So double what they usually get. State of emergency, remember that? Remember the big trucks going down the road, carving the snow? They had these big, the thing that was just cutting the line in the snow and then blowing in the trucks, and then they were hauling the snow, I think, to the river to try to get rid of it. Several collapsed roofs. The one I remember most, I think part of the mall in Sault Ste. Marie, Ontario collapsed during this event. A two-phase system. The rarest part is this one right here, this Lake Huron enhancement. This was a lot of lake-enhanced snow. Sault Ste. Marie, of course, is famous for its lake effect snow. That's why it averages about 120 inches a winter of snow. But it's very rare to get Lake Huron enhancement, and I'll show you that satellite here in a second. And of course, the more familiar Lake Superior, but still, to get that amount of snow with lake effect in a day is extraordinary. We're going to focus in on those dates, December 8th through the 12th. You can see we got 4 point. That was during the evening hours, and things really ramped up on the 9th. Overnight, we had about that 20 inches overnight. We had the break, and then the next night into the next day, we had another 35, 36 inches of snow. More impressive, this whole winter was impressive. November, we already had a decent snowpack going into December 1st. And then look at the snowpack. Here's snow depth. It ramps up from 18 to 48 inches. I got a picture of me in a Washington Redskins jacket. I mean, basically up to my armpits in snow, and had the biggest smile on my face ever. I lived over there on Johnson Street at the time, right across from the power company there. Love and life. But look at that. Look how much moisture was in that snow. You know, that's 1.5 inches of liquid equivalent. There was a lot of moisture with this snow. That's the reason partially a lot of the collapsed roofs. But 49 inches of snow, and then eventually began to compact the rest of the month. But look at the monthly total. 98.7 inches for the month of December. Like I said, the Sioux average is about 119, 120, somewhere up in the upper 100 teens. That winter we ended up getting over 200 inches of snow, in large part because of this month. Here's that Lake Huron enhancement. What happened was we had ever heard Clippers, Alberta Clippers? Alberta Clipper coming from the northwest out of Canada. Usually in front of Alberta Clippers you get enough warm air that it's warm enough to preclude any type of lake response. Well, the air mass in that December was bitterly cold across the country, across the eastern half of the country. So as the Clipper came over, it had plenty of cold air to the south to tap. And out ahead of a low pressure, you get south winds, southeast or south to southeast winds. Lake Huron completely unfrozen at the time. South to southeast winds up across the whole length of the lake, right up the St. Mary's River, and curled in right at Sault Ste. Marie. That's extremely rare. Extremely rare.
That's 1,000 to 1 shot.
Yes, 1,000 to 1 shot. And I had a friend who was also a snow freak. He was downstate at the time. And I called him up. I said, "Hey, Dan, you ain't gonna believe it up here. It's like heaven." So him and his wife decided to jump in the car and try to get up here to see it. Well, their story is, there was nothing south of 28. M28, there was hardly any snow at all. Once they got to 28, right where that band started to curl in, he said you couldn't see nothing. They were literally sticking their hands out the window to find the snowbank on 75. And if I remember correctly, a lot of people on 75 were completely stranded. And the police officers were borrowing people's snowmobiles to go out to rescue them north of 28. So this Lake Huron band brought a good 20 to 25 inches on its own. The Clipper system goes by, and you get the more typical northwest winds, much colder air even now, coming right out of Canada, that blows across the whole length of Lake Superior. And it just happened, the wind direction was perfect. And what Dave brought up, and interesting to look at the obs, notice the clear skies across Ontario. We call this the Canadian Plateau. And a lot of times in winter what we see is that cold air. That cold air is heavy and dense, wants to hug the ground. So as it was clear here, temperatures were dropping well below zero. The wind was coming off that cold land and coming right into Sault Ste. Marie, kind of forcing the air to converge. You had northwest winds off the lake, northeast winds in here, they were converging. That creates lift, the air can't go on the ground, it has to go up. So it was just absolutely perfect. Northeast wind, cold drainage flow, northwest winds, and you can see the brightest clouds right over Sault Ste. Marie, Michigan. Interestingly enough, a study come out several years later, the heaviest snow was actually leaving the cloud over the middle of Whitefish Bay. But the winds were strong enough that that snow that was leaving the cloud was falling in Sault Ste. Marie. Talk about perfect else. Here's a snowfall map. Look at the max. 61.3 drops off rather quickly. That's in large part because of what Lake Huron is and we're right up the St. Mary's River. And some pictures. Like I said, I look at this and this is just awesome. Okay? I mean, look at the snow. I remember people cleaning off their roofs, and this is one I'll never forget right here. This is coming out of the house. My friend was, he was sleeping during most of the event. He's like, yeah, I'm gonna go to work. I said, good luck. And that's his car, and he walked out, and that's what he's seen on the top of his Ford Ranger. So, yeah, it was, I hope I see one again. I hope maybe you don't all see one again, but I wouldn't mind seeing one of these again. Okay, I'm going to turn over to Dave. He's going to go on the other extreme.
Yep, talk about heat. Heat. Something we had none of this entire year, but that's all right. Let's talk about it anyway.
How do you spell it?
Next year. That's how I spell it. Hopefully. Let's talk about the July 1936 heat wave. This was in the middle of the drought Dust Bowl years that were occurring across the plains. Of course, arguably the most severe drought in modern history in this country, and this month in particular was just absolutely insane. Let's look at why that was. This developed just after Independence Day, 4th of July holiday, lasted for over a week, which honestly this far north, I think you would all agree, is pretty rare for us to get hot and stay hot for over a week. Huge amounts of record-setting heat, absolutely huge amounts. And this still stands as the most intense heat wave in United States history, which really says something when you go back and you look at a lot of long-standing records date back at least 100 to 150 years. That's really saying something for how severe this was. And what I thought was interesting, and Mike pointed this out, is this is obviously a newspaper clipping from July 15th, 1936. And this paragraph right here says, leading the death toll is Michigan, with 365. So we, unfortunately, set some impressive records during this stretch. One of which, obviously, still stands to this day. The highest temperature ever recorded in Michigan did not happen in the UP, but happened not terribly far to our south, over in Mayo, at 112 degrees. That happened during this stretch. That still stands as the hottest temperature recorded in Michigan. And one of the interesting things is, people ask a lot of times, why don't we, it's rare for a lot of places to hit 100 in Michigan, especially this far north, right, this time of year. But what a lot of people fail to remember is what happened in Michigan back in the early 1900s. There were hardly any trees left. They had completely deforested most of this. So that essentially changes the entire climate. You have sandy soils to begin with, which heat up very easily, and especially in the face of drought, which was ongoing at the same time. Those soils were very dry. So as soon as the sun came out each day, up went the temperatures, and they stayed at some pretty intense levels. And here's really staggering. The nation's death toll exceeded 5,000 in this month alone, July 1936. Do you remember what the Chicago heat wave was? 95? Like
95.
What's that?
Yeah, 95.
Yeah, do you remember how many people died? It was like, it was way up there. It was one of the, I think it was the second or third most, but July of 1995 was another similar style of heat wave, of course preceding the crazy winter that followed. And I believe there was almost 600 people in the city of Chicago alone that died during that one. So these things aren't terribly rare in the course of history, but this one certainly set the standard by which we measure things today. So let's take a look at, I'm going to show you some of the interesting maps that we put together, show you just how warm it was. But the key thing that played into this was poor land management. It's no surprise. The farming techniques that we use now, especially out in the plains, they had no clue what they were doing, to be honest, back in the 30s. They were just figuring, we'll plant crops, hopefully it'll rain enough, and then the cycle continues. Well, when those crops withered and drought began to expand, those fields are so sandy and dusty, and there was so much wind during this period that basically it scoured all of this dust. In fact, there are reports, and this was actually well documented, dust from Nebraska and Kansas ended up several times in downtown Washington, D.C. during this month. That's pretty amazing if you stop and think about how far that has to travel. So without vegetation and with low soil moistures, the plains were basically just became, as I like the way Mike put it, became a furnace that just continued to sort of build on itself and build and build. As the temperatures continued to climb, the soils got even drier, and it was just this nasty pattern that kept going and going and going. Let's take a look at some Sault Ste. Marie temperatures, and we'll also show you some from Marquette. Now, the Sioux, congratulations, I think, has never officially recorded a temperature of 100 degrees or more. That's kind of an interesting fact. But they have recorded temperatures of 95 degrees or higher 23 times since 1888, okay? 4 of those occurred in July of 1936 alone, which is pretty amazing. And here's a look at the daily highs and lows during this stretch, and you can see, 88, 93, 95, 96, 93, 96, 96, 89, with overnight lows becoming impressively warm as well and not falling out of the middle 60s. And you can see the departures here, increasingly climbing to as much as 15 degrees above normal for this time of the year. And this is, climatologically speaking, the hottest month of the year for the Upper Peninsula, this month of July. So really, really amazing feat here. Let's shift west to Marquette. Now, Marquette is a little less protected from southerly winds. Those southerly winds coming out of Wisconsin and sort of push more heat up, whereas we have to deal with the air conditioners known as the Great Lakes, which tend to cool our temperatures down just a little bit. They have hit 100 degrees 23 times, same number since 1875 when records began. 4 of those occurred in a 1-week stretch in July of 1936 alone. And look at some of these overnight lows, 80 and 80. 101 degrees for a high and 80 for a low. A staggering 25 degrees above normal. So just really pretty cool, and not cool, pretty impressive if you know what I mean. Here's a look at temperature anomalies from the country. So this is from July 1936 as a month and averaged over the entire month. Temperatures throughout this dark red regions were 11 degrees or higher above normal. This is statistically just way off the charts. You'll never see that kind of numbers very often at all. The Great Lakes, believe it or not, were actually a bit more fortunate. We actually maintained some cooler periods, which is fairly typical, we all know, during July. But during this one particular stretch, that big ridge of high pressure, which was centered out here over the plains, briefly folded over into the Great Lakes, and that's when we had our tremendously warm stretch. Over here you see precipitation anomalies, so how far above or below normal rainfall was for the month of July. And basically, you see all of these areas in red? Almost every single recording station out here had 0 inches of rainfall for the entire month of July. So again, it just sort of built on itself. No rain, dry soils. We sort of create very dry furnace-like conditions, which of course then folded over. Here's the state ranking. It could have been a lot worse for Michigan. Here's the state ranking for 1936 temperatures during July. And you can see that essentially we were near normal as a whole, outside of this 1 week of heat, versus these areas out here, which were and continue to be to this day the record warmest month of July on record. In fact, this is actually for all of 1936. So these areas out here had their hottest year on record just to our west. So we actually did luck out just a little bit. You can see up here into Maine and parts of far northern New England, cooler than normal conditions persisted, and we were just on the tail end of that cooler air at times, such that we didn't have to endure an entire 4 or 5 or 6 month stretch of tremendous heat. Nevertheless, of course, very, very impressive. And you look at precipitation departures for the month, or excuse me, for the entire year of 1936. These areas in dark red continue to this day, 100-year records or better, continue to be the record driest year on record. In fact, there were some locations, I know in Nebraska, because I lived out there a number of years, but in Kansas and Oklahoma as well, that had less than 2 inches of rain for the entire year, 1936. That is staggering if you stop to think about it for a few minutes. Just really amazing. So that's all I have on that. But again, hopefully we'll never see anything like that, at least in recent memory. But could I have a little round of applause if you'd like at least some 80-degree warmth? Anybody wants that? That would be nice at some point, you know.
Get that thought out of your mind.
Yeah, we don't want that in December. I'm with Mike. No, I'm done with heat for now, but next year would be nice. So let's flip-flop back real quick and let's talk about the summer of 1992. Anybody remember this summer? Turned the year without a summer. Now, I would argue that, and you would probably agree, that living in the Sioux, typically there's a lot of years without summers up there, correct? Yeah, I hear you. Same thing in Gaylord. In fact, this past summer was fairly cool, especially the month of July was tremendously cool for the state of Michigan as a whole. But this summer was impressive for a number of reasons. It was termed by the media, and really is a good term, the year without a summer. Prior to that, the summer of 1816, I believe, was known as the year without a summer as well. In fact, there are places in New England which recorded snow all the way during the month of July. all the way that late in July. It was so cold. But this one is obviously much more fresh in our memory, and we have much more available weather data to talk about it. So why was it such a cool summer? There's a number of reasons, there's a number of patterns that develop in the atmosphere, but one factor that is well agreed on was we had an eruption the prior year, in June of 1991, of a very, very large volcano, Mount Peninsula. Does anyone remember this event? Very large. Now, eruptions like this happen all the time. You know, I mean, volcanoes are certainly nothing new, and it seems like every other day you'll hear about one going off somewhere in the world. But what made this one interesting is its placement on the Earth in terms of the Northern Hemisphere. Most of the volcanoes that erupt are, of course, on the Ring of Fire, and a lot of them are in the far northern latitudes, or maybe up in toward Iceland or Greenland, up that way. You're talking way removed. They're up far north of 50 or 60 degrees north. So the ash clouds that develop from those tend to transit the Earth at much higher latitudes. This one, on the other hand, occurred down here not far from the equator. This is the location. And of course, here we are over here. And this is sort of the average jet stream position during this time of the year. In fact, you can see already what was established was a trend for winds to be northwesterly out of Canada and transporting cool air already in here. But what also played into that fact was when this ash cloud went, it expanded like this. And then, of course, jet stream winds took it around the Earth. So a volcano that may erupt, say, in Alaska or maybe way up here north, most of that stuff tends to stay up here and circle the Earth at the very high latitudes. This one coned out and went crazy. In fact, there's documented evidence that that volcano alone lowered the average temperature of the Northern Hemisphere by 1 to 2 degrees Celsius, just from volcanic dust a year later from that. So that certainly was not playing into our favor as we went into the summer of '92. Here's a look at the average temperatures, similar maps to what we looked at for 1936. This is for all of 1992. If we look at the year as a whole, 1992, this is one of the coldest years on record in the Great Lakes region, and especially the summer, and that's what we're looking at here. This is June to August 1992 temperature departures, and you're looking at values, of course, through this region, essentially anywhere between 4 to as much as 7 or 8 degrees below normal. So a very, very chilly month, similar to, not terribly dissimilar from what we saw here recently, back in the summer of 2009. Does anyone remember this event? Sort of another rip-off summer in our long history of them up here. Yeah, you can see here's a comparison map, same time frame, just a different year. Temperature in 1992, temperatures in 2009. Not quite as cool, but this is the year of the infamous, every time someone in our office decided to go do something outside, things went wrong because it was so cold. Just not good. The one day it was supposed to be 75. This was back when the Mackinac City had a water park. You guys know that they obviously tore that down. The forecast was 75 and sunny. Our one of 3 allotted warm days we get in the summer up here. Jim Kaiser, one of our guys in our office, decided it would be a great day to take the kids to the water park, and they got up there and it was cloudy, drizzly, wind off the water. It was like 51 degrees, 49 degrees. He said they basically just let them walk in because they were crazy. We were going to make them pay to go in.
No lines at all.
Yeah, no. Free rides, everything. So, this was the year where 2009 was another year where 4th of July fireworks. Anyone ever seen the beautiful view, obviously, from Mackinac City? You can see multiple locations. Everything was great at sunset, which is, of course, very late that time of the year. And the air mass was so cool, passing over those warmer lake waters, that as soon as it did so, it fogged in completely, and all you could hear were thuds with little bursts of light in the fog bank up there. So just one of those interesting types of setups that we're famous for around here, but this is still pretty impressive, even as close as 2009. But 1992 still maintains the records around these parts for cold summers. In fact, let's look at some cold mornings recorded across the state. 31 degrees right here in the Sioux. That was on June 22nd. That's pretty late in the year to be getting 31 degrees. Tacoma Falls, we don't know, it's a pretty chilly spot. Okay, no one would argue with that, but 26 degrees in late June, that's unheard of. Here's Tacoma Falls again, because one sub-freezing night wasn't enough. Let's go a month later, July 21st, 29 degrees. Okay, that's not cool, especially if you're trying to grow stuff. Marquette, this is in town, surrounded by, development and things like that, tend to be a little bit warmer, 32 degrees. 28 here in Ironwood. And this one was very impressive. Newberry, 21st, 32 degrees for July. So very, very chilly low temperatures during this month. Mike, you want to talk about winter?
Yeah, I'll talk about winter.
Are there any questions about anything we just discussed? No?
Thank you,
So
sir.
this was a good winter.
That's fun.
Anyone think last winter was cold?
Yeah.
Okay. Yeah, last winter was extremely cold. In fact, I think Michigan had its 10th coldest winter on record as a whole. And a lot of the upper Midwest seem on in their top 10 coldest winters on record. But you know what? We still compare it to these winters. Anyone here in the 70s, late 70s? Okay, I was a little kid back then. I was 8, 9 years old. And I remember still that they were saying the new ice age is coming. The new ice age. Okay? Yep. From these winters. These winters were historically cold. Look at these temperature anomalies. This is a departure from normal. November to March, so encompassing the late fall and early spring season in 1976, 1977. You know, temperature departures, 5 to 6 degrees below normal, especially across the southern lakes and northern Ohio Valley. And as David mentioned earlier, you start seeing temperature departures on a seasonal average like that. That's extreme, extremely rare. 77, 78, centered a little bit farther to the west, but the same departures. Bitter cold winters. Like I said, these are winters that other winters are still compared to this day. Another thing that happened, 77, 78, not so much here in the Sioux, was the famous snowstorm of late January. Anyone recall that? To this day, it's probably Michigan's greatest snowstorm. Now, it hit mainly, like I said, south of the bridge. And that went all the way down the Ohio Valley, but they had, recorded 20 to 30 inches of snow, sustained winds of 50 to 60 miles an hour. There was a report off Cleveland in the January, what they call the super bomb, wind over Lake Erie of 112 miles an hour with heavy snow. And it was all part of that bitterly cold winter. But notice an overlying theme here. Cold east, look where it's warm. Okay? You see this a lot, and last winter was a textbook example. What goes up must come down. Ridge, a lot of heat. And like Dave said, those jet streams do this. So the heat comes up, grabs all the cold air here and brings it right down to the Great Lakes. And a lot of times when we have our bitterly cold winters, people out west are experiencing record warmth. And I think, did we have the slide for this last winter?
Go ahead.
I'll show you that here in a second, but the extreme. In fact, here it is. This is last winter, same time period, November to March. Departures -7 degrees below normal for the late fall through the winter and the beginning stages of spring. Look out west. California had their warmest winter on record and one of their driest. California's wet season is the winter. They got no precipitation. Now, if you've seen any maps on the news lately or any of the images, the lakes in California are completely drying up. And that was in large part because they had no snowpack last winter. Why? Heat dome brings all that comes up, extends up here into the Arctic, grabs all that bitterly cold air. Look where it's headed. You get a nice wavy pattern in the atmosphere. We happen to be in the downward branch of one of those waves. But let's look at 1976 again. Cold began in earnest in October and persisted through early March. Quick moderation in spring. Believe it or not, the spring of 1977 is one of the warmest springs on record. The pattern completely flipped about late March in 1977. But before that, it was bitterly cold. Cold was far-reaching with Lake Erie completely frozen over by New Year's Day. And Lake Erie is one of the earliest lakes to freeze, even though it's a little bit farther south. Why do you think it freezes quickest?
More shallow?
Extremely shallow, exactly. But by New Year's Day, that's impressive indeed, for even Lake Erie to freeze. Ships became stuck in the Chesapeake Bay, and I believe that is an image of one of those ships in Chesapeake Bay that was stuck. And in 2013, to compare, cold began in earnest in October, persisted through April. Last winter was actually more drawn out. In fact, I would argue we haven't got out of the winter yet. So you can go right through April, May, June, July, August. We're just getting ready to start the next winter.
I think we had 1 week where it warmed up to 65. Right?
Yeah, I think we hit 65 already. The upper level pattern that I had mentioned earlier. These are what do you call 850 millibar air temperature anomalies. Red, I'm colorblind, so you gotta excuse me. If I say something's red, it's really like
It's red.
It's in red?
It's red.
Okay, that's red, that's a good thing. Look it up here in Alaska. Temperatures well above normal. This is anomaly, so you're talking 4 degrees above normal. This is just off the surface, about 5,000 feet. Alaska had an extremely warm winter last year. Where do you think all the cold air is that's normally over Alaska? Where was it? Yeah, right here. Look at the Arctic. Up here, Greenland, north up through the Arctic Circle, above normal temperatures. That cold air has to go somewhere, and guess where it shows? Right overhead. Was that like?
That was 1977.
That was 1977. My fault, Dave. That's 1970. So I keep flipping back and forth. But look at the comparison. That was 76, 77. See a whole lot of change? Not really. The cold anomaly may be centered a little bit farther north, but look where your warm temperatures are. Out west, up through Alaska, and over the Arctic Circle. If it's warm up there, now it's relatively warm. Granted, it's still cold up here. But if it's warmer than normal up here, the cold air has to go somewhere, and it happened to settle right overhead last winter and in 1976, 77, and 77, 78. This map's a little bit harder to read. These are the coldest temperatures observed in the UP in 1976 and 77. The Sioux, what's that say there? Negative, I think that says negative 30, negative 31, negative 36 just to the south of the Sault Ste. Marie. The coldest, I think, what'd you say it was, Dave?
46 below, I think, was it, or something like that? 41 below?
41 below in the western UP. Just to compare, anyone know what the all-time coldest record or reading in the state of Michigan is? It actually happened south of the bridge, Vanderbilt. 1934 hit minus 51 degrees. The winter of 1993-94, never recall that winter? That was another extremely cold winter. In fact, the ice cover on the Great Lakes last winter rivaled the winter of 93-94. It's probably maybe one we should have included. There was towns out here one night in 93-94, I think it was February or late January of 1994, where thermometers hit 55 degrees below zero. And they did some studies, and they determined that the thermometers weren't accurate enough to displace the record that was still in Vanderbilt in 51 degrees below zero in 1934. But bitterly cold temperatures throughout the UP. Look at the number of days below zero. Like I said, pretty hard to read, but I think that's 48 in the Sioux. Some places in the 50s. These are amount of days below zero. So these are mainly overnight lows anytime during the day, but mostly overnight lows that exceeded or went below zero. 64. Dave, you recall any other higher ones?
That was the highest.
64.
What was that term you just used?
For?
Some amount of days below?
Yeah, the number of days for the winter season that were below zero, and that includes overnight lows, daytime highs. Most of these were probably overnight low temperatures, where your coldest temperatures are observed. These are number of days where the thermometer actually recorded below zero readings. Let's compare it to last winter, 76, 77 to 2013 and 14. Coldest temperatures, the Sioux minus 27, minus 30 is just to the south. Not quite as cold in terms of actual readings, mainly negative, lower 30s, negative middle 30s for some of the coldest readings. However, when you look at the days below zero, these numbers are tremendously higher. 84 out there like towards Ishpeming, Nagani. Sault Ste. Marie last year had 70 days where the temperature was actually below zero, compared to the previous record, which was 48. So last winter, if you thought it was cold indeed. I think that's all I got, Dave. I'm turning over to
Let's do it.
tornadoes.
Yeah, anybody have any questions about that? One could argue in this parts of the country that last year's winter was more severe than the 76, 77 winter. From a number standpoint, the entire state, it was the 10th coldest, but I think if you draw a line, I'd say north of about M55, of course, right where we live, up north, keep going, I would argue it's probably a top 3. In fact, if you look at specific cities, it's a top 3 coldest winter.
Gaylord had their coldest winter on record. I don't remember the Sioux.
I think it was second.
Maybe second coldest, yeah.
It doesn't matter, really, it's just a numbers game. It was cold. And one of the things that fed into that, especially with these, I mean, think about 84 days during the winter where you saw a temperature below 0. Think about that for a second. Or you guys 70. Does anybody have a reason for that? What do you think the numbers last year might have been higher? Anybody have a guess why that might be?
What about that the ice over Lake Superior kept any moderation?
Get yourself a cookie. You just answered correctly.
I also wanted to say that last year here in town, it was really beautiful. The streets were white. There was no brown stuff. It was a very clean and bright winter. I thought
It was pristine
terrific.
snowpack because it snowed every day to freshen it up a little bit. Yeah.
I thought it was beautiful.
No, and actually, I agree with you. I took notice of that myself. We had no thaws, not one single thaw during the entire month. And if we did, I think we had one in Gaylord, and I think it got to 44 for about 3 hours in early December last year. And then, of course, here came the next wave of cold air coming down.
Now, there is good news about that lake freezing. Your snow, by the end of like January, really cut off. In fact, it cut off for much of the area because we lost, all the lakes started freezing. Without lakes, you know, we lose a lot of our snow up here. So yeah, we got a lot of clear days because of that ice pack, and those clear days led to some awfully cold nights.
Yeah, because essentially what normally is a great air conditioner or, you know, kind of a heater, I guess, in the winter, to keep that really cold air from pouring south became essentially a landmass. So all that stuff that's usually stuck up in Ontario where it's bitterly cold said, "Hi, what the heck, let's go across the lake because there's nothing left there to stop it." And boom, right down it came with basically no barrier left whatsoever by the time that lake was frozen. So just really, really, really amazing. Now, let's switch gears. Talk about tornadoes of the UP. This ain't Kansas, correct? Not exactly. This is from Dexter, Michigan. This is not from the UP. And the reason for that is because it's insanely hard to find a tornado photo from the UP. They just don't exist, although I did think this is a really cool photo. And if you ask me, this guy might just be a little bit too close to this tornado, but that's not for me to decide. I mean, that's just right behind this tree line here. That's not that far away. So.
Was that the March heat?
That was the March heat wave.
That was a good thing.
Yeah, we can talk about that too. There's just so much. The UP, I mean, the weather in Michigan is just this is, as I often tell people, forecasting in northern Michigan is one step shy of a disaster. It really is, because even last night we had a beautiful night, high pressure building over. It was a cool night, and everything was fine until the wind went easterly off of Lake Huron down, and not so much up here, I don't think, but just south of the bridge. And what did that do? Here comes a huge bank of low clouds pivoting in, which then stuck around the entire day from Grayling on south, where I think Grayling's high temperature was like 40 today. You know, high pressure. It's supposed to be nice weather, right? No, not in Michigan. High pressure is terrible in Michigan. So, just a really interesting place to forecast. But we thought we'd throw in at least a quick segment, because they are fairly rare for the UP, of reported tornadoes since 1950. And I really like this map. This shows all of the reported tornado tracks since 1950. And there have been exactly 60 that have been reported. Some of them are a little bit harder to see. They're really tiny dots. And you'll notice a lot of them are very short tracks, with a couple of exceptions. You have one really, really long track tornado here, another one down in this region, but just a lot of little tiny things. Now, I will not go all that far out on a limb and say that this map is more than likely very incomplete. The population density in a lot of the UP, as I'm sure you're all aware, in many areas, especially this chunk of wilderness, is less than 5 people per square mile. It's actually the lowest population density of any state east of the Rockies. Happens to be in Michigan. So the amount of reports that we can, of course, gather from such places when severe weather happens, you know, if the trees could call us, we'd know a lot more than if people call us, you know what I mean? So, but just an interesting setup. And one of those in particular, does anybody remember this event from 1992? This was, believe it or not, during the very cold summer of 1992. There was a large but very, very small track tornado that occurred in the town of Gladstone. Injures several people. Thankfully, no one was killed. It did an estimated $1 million in damage, which for the UP, is pretty impressive for a tornado. And it only, like I said, only injured a couple of people, but it was reported to be about a half a mile wide. And it actually dropped right in town. And here's the amazing thing about this event is there's actually a photo of a UP tornado. It's the only known photo that I could come across looking for the last 6 months
of a well-documented tornado that occurred in the UP. There was a similar setup to this tornado that almost impacted Marquette a few years ago. Anybody remember the large Marquette hailstorm? I don't know if you've heard about that event, but there was very close to being a very large tornado that developed that would have tracked through Marquette, but the air down near the surface where these tornadoes kind of sort of have to punch through was too cool because of Lake Superior. There's a nice little stable air down here, so instead of developing a tornado, it just decided to produce quite a bit of very, very, very large hail. So I'm not sure which is worse, but very interesting setup. So this is actually one of the only few well-documented tornadoes of the UP, so I thought this is kind of a really interesting one to touch on. So
You don't
there
know
has
where
been.
that was?
What's that?
Do you know where that was?
This tornado?
Yeah.
I actually found it on Google Earth.
That's Gladstone.
Yeah, this is in Gladstone.
Is that- oh,
Yeah, this
okay.
is the one right here where we're talking about.
Oh, okay.
Yeah. And yeah, pretty interesting. So it's not in color, but it'll have to do. So we'll take that. So that's all I have on the tornadoes of the UP. There's just not a lot up here. The conditions that we need to get them up here don't happen all that often. Typically, we just have too much influence from the Great Lakes, and same thing really in the lower peninsula. But you know, you're surrounded by water on two sides, especially the eastern UP, and they just act like tremendous air conditioners. I've said that several times. But they really do. They really help to sort of just focus our weather toward the cooler side of things and keep a lot of this heat and moisture that we need. And you'll see that. Look how many more are reported in Wisconsin. It sort of keeps that at bay from working too far north.
And the eastern UP, there's hardly any of them.
Yeah, there's one actually, yeah, up here.
Yeah.
A lot of these, this I believe was a water spout. It briefly came on shore, and I'm not sure what year that was, but I looked it up, and I don't know about a couple of these. I think one of these, this one out here might have been a water spout on the St. Mary's River that happened to come on shore as well. So very, very rare for them to get up here. I do like this one way up here on the Keweenaw. That's kind of an interesting place to have. We don't think of them too much up there, so pretty neat stuff. So, all right, I think our final topic.
I'll let you do that one, that's your expertise.
Oh, yeah, I'm the fire weather guy at the office, so I work a lot with the fire weather folks in the state and stuff like that, and have a kind of a pyro, I guess, just a little bit. So. Never set any fires, don't worry about that. Yeah, this was my backyard last night. You know, yeah, it's time to get rid of this. Oh, this is pine straw, the dreaded pine straw. Can't seem to get rid of. This is going to be a little bit hard to see, but here's a list of essentially the largest fires that have occurred in Michigan in the last 100 years. By far, and we're going to talk about this event here in just a minute, October the 8th, 1871, keep that in the back of your mind. That is an infamous date for fires in Michigan. That occurred, of course, back when clear cutting was really getting going. They would come through an area as Chicago was building up, and we needed lumber for somewhere. Came to Michigan to get it because it was cheap. And so they clear cut these areas, so they sort of leave these huge piles of slash laying around and maybe a stand or two of trees in between, but not much. And these huge piles of slash would sit there for 3, 4, 5 years. Most of it was pine and other types, but it would dry out and then wait for something bad to happen. And something awful happened on October the 8th, 1871. So we'll get to that here in just a minute. A couple other fires in a little bit more recent memory. The Seney Fire, August through October. This was a very long burning fire, 1976, burned about 78,000 acres. And we'll talk about this one here in just a minute. Duck Lake Fire up this way, Lewis County, was about 21,000 acres. That was just 2 years ago, 2012, May through June. Oh, yeah. And probably the most infamous outside of this is the Mack Lake Fire. Anyone ever heard of this one? This occurred in May 5th, 1980, over near Mile with 25,000 acres. But unfortunately, it actually killed one person who was an employee of the Forest Service that was trying to escape the fire in his tractor. He was trying to cut a fire line and it overtook him. This fire should never have burned. The Weather Service screamed and screamed and screamed, do not. It was a prescribed burn that went awry. There was a strong cold front coming in. The timing of the front was expected during the late afternoon hours for peak heating, where it's warmest and most dry typically. With a strong wind shift expected, obviously with that front, you're talking about May. We're trying to warm up. You know how this works, but we're not quite there yet. So we get these little warms and then cools and warms and cools. This is a fairly strong front coming through. Strong winds from the northwest up to 40 miles an hour expected behind this front as cooler air came in. And they said, nope, we can do it. We can have it mopped up before the peak time was 3 o'clock to extinguish this prescribed burn. And the front was about 1 hour faster than what was initially expected. So 1 hour took this fire from about 6 acres to 25,000 acres just because they decided to set this thing off. And like I said, unfortunately, one gentleman was killed, as well as 44 homes being destroyed from this one. So let's go back before, I don't have a whole lot on that one because that was obviously in the lower peninsula. Let's talk about what happened on October 8, 1871. And I apologize for these grainy maps. They're pretty hard to come across these. We're looking, this is the Door Peninsula, of course, in Wisconsin, and we're looking out toward Menominee, out this region way out west here. And there's a little town, and I'm not sure how you pronounce it. It's either Peshtigo or Peshtigo. It doesn't matter too much for whatever purposes here. But these slash piles were laying around, and sort of just, like I said, waiting for something bad to happen. We had strong low pressure that developed out here just to the west over Minnesota and parts of the plains. Out ahead of that, of course, lots of warmth on southwest winds that were gusting anywhere between 30 and 40 miles an hour. A nice October day, actually, in Michigan. Temperatures were warming into the 70s and 80s. So this is those days, this time of year, where we just soak it all in, you know what I mean? Because you just know what's coming. Unfortunately, it had been pretty dry before this front was approaching, and just waiting for something to sort of spark it off. And in many cases, you're talking 1871 here, it would be a fire burning at a bakery, or a fire burning, some reason for somebody to actually have a fire ongoing. Maybe a blacksmith, maybe someone that needed to cook with fires. And in the case of this, I'm pretty sure, I'm not positive, but I'm pretty sure this was a kitchen fire that near the town took off. And of course, with winds gusting 30, 40 miles an hour, it just accelerated across open country, which by this point was nothing more than, again, slash piles and basically grass fields that were drying out, because this is fall by this time. And so this fire took off and burned all the way up here, and essentially burned all the way as far as it could into Lake Michigan, toward the northern tip of Green Bay there. What's famous about this event, not only, of course, because it impacted parts of the UP, a small part, but this poor town of Peshtigo, 1,700 people were killed in less than an hour as this fire burned through. It remains actually the worst fire in U.S. history in terms of deaths, which is really hard for us to imagine, because we have so much fire suppression now. We put these fires out with helicopters and all these really amazing things. But 1,700 people perished in less than an hour from one fire. So really kind of a sobering fact. And what makes this even more interesting, it was part of a larger contingent of fires that were burning on this day. How many people here have ever heard of the Chicago fire? Very famous, very, very famous, of course, because it happened in Chicago. What most people don't realize is that there were multiple large fires burning the same day. By far, there's one here near Holland, there's one up here in the Thumb toward Bad Axe, which actually burnt the entire town of what was Bad Axe at the time. And there's this one, which, if you look at this is one of these fires, you see these fires out west, well, they'll burn for months because they'll get into trees and it's just hard to stop them. If this body of water hadn't been here, there's no doubt in my mind this fire would have raced way up into Ontario, perhaps even Quebec, and burnt the entire strip. And of course it ran into, loss of fuels here. But imagine a fire burning all of M55 for a minute in one day. One day, the fire burnt from Manistee to basically kind of Oscoda, just south of Harrisville, that area, in one day, that fire burned. And that is representative of about 1.5 million acres burnt in one afternoon. That is impressive. I don't care who you are, that is amazing.
That's funny. I hunt down in Harrisville, and the property I hunt, you can still see the burnt cut stumps, from when they log. You can still see the charred stumps from that fire.
That's amazing.
Yeah.
Hot, an extremely hot fire, so.
You have a figure for the advance speed for something like that? I mean, it was like 3 hours to go all the way across.
Yeah, you're talking, I don't know what the distance is, but some insane forward flanking speed, probably 30 to 40 miles an hour for a fire. I mean, you can outrun it. There's nothing you can do if you're in the path of that. Just get out of its way. I don't have the death total from that. I know there were people killed. Outside of the town of Manistee, which was completely burned. We lost a lot of cities that day in Michigan. Manistee was completely burned to the ground that day. And I don't believe there was a lot of other large towns in its way. I believe it went just north of Houghton Lake, just north, and then just to the north, between Harrisville and Oscoda. So a lot of open country. There still is to this day a lot of open country out there, but still a very large fire nonetheless. And just to put things into perspective, because a lot of people in Michigan that haven't experienced wildfires, they always say, Michigan has wildfires. Yeah, we do have wildfires up here. And anyone remember Duck Lake 2 years ago? Very famous. I'm sure you probably see the smoke at times from here. See the smoke column or something like that if you could find a clear area. This was a lightning-induced fire, burned from just shy of a month, May 23rd to June 15th. And what I love about this picture is you'll notice, very similar to the one that burnt across the lower peninsula, this sucker burnt all the way until it got to the big lake. and decided it had nowhere else to go from that point. It actually started backing back down to try to find more fuel as it got to the lake shore. And here's a map, it's kind of hard to see, but here's 123 and 123, and this entire area that was burned in through here over in Luce County, all from a lightning strike. That was about just over 21,000 acres with 136 homes and businesses lost, I think including, there was one campground over there that was completely burned out. But thankfully no one was hurt from this one, so that's always a good one. That's all we have for the evening. That puts us at about an hour and 15 minutes. Do you guys have any questions about anything? We will entertain such questions. Whew.
Wow. Last winter, they kept talking about a polar vortex.
Yeah, okay. You want to know what is the
Well, how
polar
did that
vortex?
relate to the map you showed of the temperature anomalies and
Pull up that winter.
Yeah, that's actually what I was going to thinking. Okay, let me pull up another presentation here real quick and I'll explain that briefly. Where is it? Winter.
Winter Summit? Is that- Oh, it's up there. Right. One.
Oh, Winter Summit, yeah, okay. Jim moved, where did he move that to? That's in John's?
John. Interesting you bring this up, because last year we had, and Dave can attest to this, during the late winter, we were getting call after call about this polar vortex.
Yeah.
And the media made it sound like it was something completely new, no one's ever seen. And you'll find out here that it's actually supposed to be there. It's there all the time, but it made some frequent stops last year.
Yeah, essentially the polar vortex is an upper level area of low pressure that exists somewhere between about 10 and 15,000 feet in the atmosphere. It gets its name because typically it resides much closer to the pole. It's a vortex, it's a circulation center of typically quite cold air that sits anywhere in this region up and through here and spends, storm systems around it, different things like that. And there's, again, lots of cold air associated with it. Well, last year, remember, as Mike was explaining, we had a large ridge of high pressure that nosed its way the heck up into Canada, okay? And we also had a large ridge of high pressure that built up over the central Atlantic up into Canada. And what those two systems did was essentially grab a hold of that vortex and drag it due south. And you can see this was from last winter. This huge area, circulation center of very cold air temperatures aloft. That's what's known as a polar vortex. We've kicked that term around. We're geeks, we're weather geeks, and we use terminology that most people go, what in the world are you talking about? But polar vortex, like I said, is one of those things that it's been around forever. As long as the atmosphere has been in the circulation state, it's been there. But the media loves buzzwords. I don't know if you guys know that, but they love buzzwords and they love to scare people about certain things. So this polar vortex just sounds ominous, and we can get some ratings with that. So that's where that came from. In fact, there was a notice at some point that came down from on high in the Weather Service to please stop using the term polar vortex because it was getting out of hand. There was Twitter hashtags of polar vortex. There's shirts, I survived the polar vortex. Have you seen those? It's just like, come on, people. I'm all about making a buck. That's cool, but
See that pattern there?
Oops.
That pattern you see there is typical of every major or cold winter on record.
Yep.
In order to get cold, extreme cold winters, you need that warm air to go up across the globe. Because that cold air, like I said, only has one place to go, and that's south.
Yeah, instead of being up here, it gets shunted right in our
Now, what
direction.
happens sometimes, the previous winters, this cold air mass settled over in Siberia. Well, last year it happened to be our turn, just like in 76, 77.
So we're done with it, right?
It's
their turn over there.
Thanks for the...
Yeah. Do we have to answer that question? Well, maybe we might if you guys don't have any more questions.
Well, you heard
we might
about
get to
the winter talks coming up, right?
Right, next week.
And you're gonna, if you want to be here for the winter talk next week, which is gonna, I think that's gonna be us doing it, that slide right there you're gonna see in the winter talk. We're gonna explain all about it, but yeah, we'll save those goodies for
Yeah, you have to come back and check it out. We'll give the full winter outlook,
the full
actually.
winter outlook.
So, did that answer your question, sir?
Yes.
Okay. Yes, ma'am.
What were your totals for the ice cover on each Great Lake?
Got a picture of that too.
Is that in
Look
this
at
one,
this,
too?
we're ready. We are ready.
Is that in this one or the other one?
That is in the winter outlook.
All right, nobody look at the end.
Well, there, just show them what we think it's gonna be.
What's that?
The title slide there.
This one?
Yeah, that's what we think's gonna happen.
Yeah, that's right here.
That's our prediction, just to
Yeah.
let you know.
That'll be each and every one of your backyards. This was in Gaylord last year. Take it in, Gaylord. So that rivals pictures you see in the past of monstrous snow years. But here is the ice cover on the Great Lakes. What date was this? March 8th. Yeah, new Lake Michigan ice record was set with 93.29% completely covered. You can see, of course, Lake Superior darn near completely frozen. And here's a satellite image. And as I was talking about, those things that are normally bodies of water suddenly become bodies of land for all intents and purposes. And just a couple of fractures here on the shore and a couple down here. This one's actually interesting. This is, even in the coldest winters, this area tends to stay mostly, not completely, but mostly unfrozen. And the reason for that is the current, the circulation current comes down in through here and is the strongest as water loops back out of this system. So this water tends to be churned up, mixed up quite a bit compared to this stuff up here where we have a lot more islands and protection from other bodies of water like Green Bay upstream to keep the water from flowing and moving around quite as much.
But do you have your percentages per lake? What was the ice cover
The total percentage?
for each lake?
Oh, I don't know off the top of my head.
I don't know, what's the total percentage there?
This was 90.8%.
This is all the Great Lakes, and that includes, if you look at Lake Ontario, which is usually the latest, it hardly ever freezes.
Yeah.
That includes a big chunk of open waters. You take that away, you're probably talking 90, well into the 90s for each of the other Great Lakes.
Yeah, I know there is a value, honestly, I just don't know it off the top of my head. I want to say it was just shy of 95%. That sounds really right to me.
Yeah,
But honestly, by the time you get that high, I'm not sure.
Yeah.
It's an insane amount. It's one of those almost once in a lifetime type of
we have
setup.
the picture of, that's Lake Superior, Memorial Day weekend. I love the lifeguard. It must be
Did all the
some.
ice melt in Superior?
What's that?
Did all of the ice melt?
Yes, all the
And all
ice. The last document I heard was the end of some spot. I think it was it you that told me? Someone said that they talked to someone in Marquette. The last reported ice they seen was like the end of June.
Yeah, there were still a
I
few
was
chunks
driving
floating.
across the UP on the 10th of June, and the weatherman said he said, the Great Lakes are officially free of ice.
You looked out. You didn't hear it from us.
No, but that's what he said on the radio as I was driving.
Okay, I
And
can
I
believe
thought,
that.
oh,
Yeah,
wow.
that sounds about right. Anything past mid-May is crazy, so that's pretty impressive. My favorite picture of this was, you probably saw people swimming out there, and one guy took his beer and just set it on a little ice cave on there to keep it cold. I said, that is enjoying life right there. You gotta take advantage of what you're given, and why not? So, poor girl, man, she's bored out of her mind. But there's crazy people out there, so they'll do it.
Yeah, there's kayakers
It's
out there.
Memorial Day, you gotta start summer.
Yeah.
Good question. If you're interested, we can look that number up for you too and see if we can find the actual total. Yes, ma'am.
I was wondering about the summer of 2013, like around at the end of July. We had a really bad storm and tornado warnings.
Oh yeah, the Justin Arnott tornado. Yeah, I think if it's the same one I'm thinking of.
You talk on it.
Did you get some confirmations of tornadoes in the area?
Unfortunately, no. I think what spawned that, first of all, we had some good looks on the radar that there was hints of something on the ground or potentially getting ready to reach the ground. If I'm not mistaken, we had a police officer confirm a funnel cloud, and that's what made us pull the trigger on the warning. But we never had a confirmed touchdown on that storm. And if you hear of one, that'd be great to let us know, but we never, because we have to try to prove every one of our warnings. And we searched high and low for that and never had anyone confirm a touchdown for us. But yes.
Good news for you, bad for us.
Yes.
As you were saying, last winter, there wasn't any thaw. And
No.
usually there are a couple of
Yeah,
thaws
there's
in a
usually-
winter. So how much chance is there of our having another winter, this coming winter, where there would be no thaw?
Very slim. Historically speaking, it actually has never happened. Even in the triple bad winters of the late 70s, which we talked on, the winter that followed that really cold 76, 77 was still cold in its own right, but featured a lot more normal type of a regime where it would get cold, really cold for 3 or 4 days, then it would warm up for a few days. And more of what we're used to. Highs, warm is relative. Highs back in the 20s and things like that, but certainly not these days on end where your high temperature was 2 or something like that, which was a little extreme last year.
Yeah, because I had ice on my roof that
Yeah.
was that thick at least, and when it came down, it did a lot of damage.
Yeah,
Oh, I can imagine.
And I have a metal roof,
yeah.
so I'm hoping that doesn't happen.
Yeah, I don't think you have too much to worry about from that perspective, but
Same situation.
very, very interesting winter. Any other questions?
Unless the polar vortex comes.
No,